Welcome to the SciCon Machine Learning Tool tutorial. Today we are going to be talking about adaptive boosting or AdaBoost regression. So a little bit of an introduction to boosting. This is a machine learning technique, and it is considered an ensemble learning method, which combines the power of multiple weak models to create one strong predictive model. Any new models made are dependent on the errors of previous models, and subsequent models try to correct the errors made by the models before them. Adaptive boosting, or AdaBoost regression, has two basic steps. The first step is to fit an initial regressor to the data, in which all samples within the dataset are assigned equal weights. Following steps fit additional regressor copies with adjusted weights based on the current prediction's error, meaning that subsequent models focus more on misclassified data samples that present more difficult classification cases. Classifications are made with single-level decision-making trees, where there is one level of decision with two potential outcomes. And one tree by itself has very weak prediction power, but combining many of these single-level decision trees into what is called a forest of trees strengthens the prediction power of the AdaBoost regressor. Some trees are assigned a higher weight based on the correction of previous errors, meaning that they have more say in the final prediction than trees with lower weights. This is a visual of how the AdaBoost regression works. So you have your original data set, you run a decision tree on it, and an initial regressor is established. Then you modify the data set by assigning weights to some of the misclassified data labels. Then you run another decision tree on those and come out with a modified regressor. Then you keep doing this, assigning weights to misclassified data points until you have a regressor that fits the data really well, and then you can get that accurate prediction. To evaluate this model today, we're going to be using the coefficient of determination, or R-squared value, which indicates how much a dependent variable varies when an independent variable varies. It shows how well the data fit the regression line and is represented by this equation, where n is the total number of observations within the data set, y hat is the predicted values, yi is the actual values, and y bar is the mean of all of the values. The R-squared value ranges from 0 to 1, and when it is closer to 1, that means that the predicted and actual values are very close and the model is a good fit for the data. The data set we're going to be using is phytomining data. Phytomining is the practice of cultivating metal-accumulating plant species to mine metal from soil. Features of this data can include plant species and variety, tissue type, such as roots versus shoots, individual and combined tissue element concentrations, and others. This is the SciCon Machine Learning Tool interface. I'm going to start with naming my project and adding a short description talking about how I am using AdaBoost regression to look at a phytomining dataset. I've already selected Upload CSV and uploaded my grass data. And because it's a CSV file, I'm going to select tabular as my data type. So this dataset consists of phytomining plant data with multiple input features that are used to predict a continuous response variable, which is element concentration. So that is going to be my total REE, or total rare earth element concentration in this case. For my target label, I am going to go ahead and select that dependent variable. For my method, I'm going to select machine learning algorithm. And for my class, I'm going to pick AdaBoost regressor. Now that I have my algorithm picked out for my evaluation metric, I'm going to pick that R squared value and click Perform. So as you can see, my R square value is very close to 1, meaning that the model fits the data very well. Unfortunately, this is a multivariable data set, so this graph that was produced isn't very helpful. However, what is helpful is this data within the table here. This y-test column shows all of the dependent variable data from the actual data set, and then this y-prediction column shows the dependent variable data that the model itself predicted. This has been the Scikon machine learning tool tutorial for AdaBoost regression. Thank you for watching.